All right, so this problem, number 52 on your final study guide, has 3 equations. So it is a little bit more of a rigmarole to solve this. It takes up a good page of your paper, but it's a step-by-step process. So I'm going to try to show you how you need to proceed here. But the thing is, on all the other equations, we only had 2 unknowns. If you have 2 unknowns, like an x and a y, 2 equations will do it. But when you have 3 unknowns, it takes 3 equations. Sort of like if I said you went to Walmart and you bought 3 items and they added up to $10. There's a lot of ways you could do that, $1, $1, $8, $2, $2, and $6, and so on. Well, even if I tell you 2 of the items cost the same, that's another clue. There's still an infinite array because I just said 2 of them, $1, $1, and $8, $2, $2, and $6. So that didn't do it. That didn't narrow it down enough. You need 3 clues. If you have 3 unknowns, it takes 3 clues, and then there is one solution where they all coincide. If they're going to solve, if there's going to be a solution. This is actually graphs to be a plane, which we don't really do in here, but you may have done that in a geometry class. So it makes a plane, a surface that's going in all directions. But anyway, never mind that though. For our purposes, we're just going to do this algebra process. All right, so what we want to do is create, step 1 is create these 2 equations in 2 variables. So basically make it what it was on our other problems before we hit this one. Make it just 2 equations with 2 variables. And we do that by addition method. So we add different combinations of equation 1, 2, and 3 and add them so that something drops out. And you want the same thing to drop out so you get the same 2 variables left in your 2 combinations. So we can either add 1 plus 2, those equations, 2 plus 3, or 1 plus 3. That's the only 3 combinations possible with just 3 things. So look through your variables and say what looks easiest to deal with. Nothing's really terrible here, but I'm thinking the z's are just asking to be added. This z and minus z, I'm going to start there. So I'm going to add equation 1 plus 2 and get the z's to drop out. Now you can write that down or just kind of look at it. There'll be 8x, 2 and minus 3 is minus 1. The z's drop out, negative 15 and 12. So, new equation, I'm going to call that equation 4, just to help labeling because this gets to be kind of a mess. So, now I need to create another equation. I've created one equation that just has 2 variables, so I'll create another one that just has those same 2 variables. So I need to drop z out again out of either 2 plus 3 or 1 plus 3. Okay, and it doesn't matter which one you do. I'm going to do 2 plus 3. Now, as it stands, z would not drop out. So I've got to multiply this by 4, and then it will. So timesing equation 2, I'm going to put a 4 there just to show. I took 4 times 2, and I times it through that whole equation, and it makes 20x. Let me scoot that up. Equation 2 would be 20x, 4 times 3, 4 times the z, and 4 times the 12. Watching your signs too. Then equation 3, I couldn't do this one in my head. I had to write these down, so because I'd had 2 steps going on here. If you can, more power to you, but I needed to see that. 20x and 2x is 22x. Negative 12y and 1y is negative 11y, and here's those z's dropping out again, as we needed them to. So that makes equation 5, right? We just need a number for it or a name. It helps to keep track of it. Another thing I noticed about equation 5, look at this 22, 11, and 33. Just if you want to, we could divide everything by 11. That's just always a good idea to try to simplify your equations as much as possible. So that becomes a 2x, a minus 1y, and a 3. And I like that's a little easier. So that's equation 5. So step 1 is the critical step. Once you do step 1, you create 2 equations and 2 variables by the addition method. Now you're really back to where we were on our old equations. You've got this equation 4 and 5 if things have been going well. And sometimes it helps me to see them vertically, so I'm going to write that over top of that one just so I can compare the 2. And we're really close to being done with that. Let me get rid of this. So now we've got these two equations, and I'd say step 2 is do what you were doing. Now continue to solve the two resulting equations as before. Do what we've been doing, either addition method or substitution method, now that you've got it down to a more manageable two variables. Now notice the minus y and minus y almost drop out, but I need to change the sign of one of them, so I'm going to just do the first one times the negative sign, just basically change all of its signs, and then add it to the second equation. And what's going to happen now is I'm able to add so that something drops out again, and then divide out the negative 6, and I finally have one of my solutions. X is negative 1. We need to know what x, y, and z are. Now we have 3 variables, but that's the hard part, getting the first one solved. Once you know x is negative 1, you can't jump all the way back up here to these 3 variables, but we can work our way back up with the smaller equations, the 2 variable ones. We know x is negative 1, so now we can figure out y here. So I'm going to take equation 4. Equation 4 is 8x minus y equals negative 3, and you could have used any version there. And I plug in, my known value now is x is negative 1. Solving this, plus 8, divide out the negative. Now I know what y is. Y is negative 5. Once you know x, once you know y, you can go all the way back to your original equations and figure out z. So it doesn't matter again what one you use, so I'm going to take the first equation. Again, I know x is negative 1. I know y is that negative 5, and z is what I'm trying to figure out. So I'm left to solve this equation. So that's negative 3, negative 10, and z. Negative 3 and negative 10 is negative 13 plus z. I know I'm solving upward instead of downward, sorry. Plus 13, negative 15 and 13. Finally, you get z is negative 2. And so there's the mess of it. Now put it all together. You've got your x, you want your y, and you want your z, and that's called an ordered triple. You do want to put them in order. Be careful about that. X, Y, Z order. Now, after all that work, I really encourage you to check your work. The way you know for sure you get these right, you plug that in for X, Y, and Z and see if it's negative 15. You plug it in here, X, Y, Z, and you plug it in here. You plug it into all the original equations. That's how you know for sure the solution should work for all the original equations. All right, we'll stop it.